My paper is the title, A New Method for Skin Cancer Lesion Segmentation. First of all, I'm sorry for the presentation. Unfortunately, my presentation file is corrupted. Then I would explain without the presentation. When we talk about the lesion, skin lesion, we have to know what is the skin lesion. The skin lesion is any region of the skin that have special characteristic different from the skin around the lesion. And the most serious skin lesion is the skin cancer. Skin cancer is about 50% of the cancer detected each year. And the melanoma is the most dangerous cancer from the skin cancer. It is about 70% of skin cancer death by melanoma. We have to diagnose the skin cancer, and the dermatologist monitor each patient by the naked eye. And this is more cost, more time needed for diagnosis. For this reason, the dermatologist using the dermoscopic image or the dermoscopic capturing for the image. And then the segmentation, it is the first stage in the diagnosis of the skin cancer. If the segmentation it is more accurate, then all the following sequence will be processed more accurate. Segmentation faces many difficulties. Some of them, it is the diversity of illumination, the colors of the skins and the skin lesion, also the boundary of the lesion, especially in the melanoma or in the cancer, there is a regulation boundary for the skin. To process the skin segmentation or skin lesion segmentation, we need 6 steps to implementing the segmentation. The first step, it is the denoising. We have the RGB color image and separate each region, each band of color image, the red and the green and the blue, and process each band separately from the other bands. Denoising is implemented by using median filter, and the median filter is remove the thin hair and the artificial particles and unwanted particles such as air bubbles. But the median filter, it is not work properly with the thick hair. Then we need another process for removing the thick hair. Second step, it is the air detection. Air detection, it is implemented by combining 2 filters, which are the Markov-Basis filter and the Laplace filter, and they created a new filter to detect the edge for the region. You know that the edge, it is very important in the segmentation of the lesion. By using the new filter, we can detect the edge of the lesion, and then the third stage, it is to convert the color to the color space different from the RGB color space. The new color space we have to implement it at this process, it is YUV. YUV color space, U, it is represent the illumination, while the U and V, it is the prominence of the image. It means the colors of the image. We selected from this YUV the U channel to process them. The U channel, it is used to remove the thick hair and the traces of the hair that is removed by the median filter. At this process, we use the bottom half filter with the medium filter combined together to remove the thick hair and the traces of the hair which is remain from the first stage. The next stage, it is the thresholding. This is the critical stage that is segmented or converting the image, the U image to the binary image and have just two colors, white and black. We use the also method to define the threshold. At last stage, the morphological operation, it is used, close and open operation, to remove the small particles, the small holes in the image, and that is the final stage. We get the binary image with just two colors, black and white. White color, it is represent the region, and the black color, it is represent the background. Now we can mapping the final result from this stage with the original image to get the lesion with the original color prior to processing for diagnosis. Now, to test the performance of the suggested method, we use the database from PH2. This is database. It is supplied by the expert physicians and containing about 200 images. It is segmented, a diagnosis from the expert physicians, and we get 35 images from other websites related to the skin cancer, and then the total, it is 235 images. This image segmented by the proposed method and compare the result with the segmented by the expert system, and we found that is the result, it is better than the segmented by expert system because we use the computer and the image processing for segmentation, and the experts, they use the naked eye and for segmentation. The accuracy, it is about 98% for segmentation, and we use hand measurement. Hand measurement, it is used to define or to determine or measuring the error for the segmentation compared with the expert segmentation. The Hamming distance, it is give a better result when we compare with the other methods that used for segmentation. Also, the very, very important point that the expert system difficult to segment the skin lesion. The skin lesion almost have irregular border, and it is difficult to segment it by the expert. While in the suggested process, it is segmented correctly, and we not have any problem with that. Thank you very much.